Today we're looking at electrolysis, and to get your brain thinking, I've got a bit of a revision question here which links both electrolysis and work that you've done in C2 on bonding. So there are four models in the picture, and you should definitely recognise 2, 3 and 4 as you're expected to do by the exam boards. But what are they? When they are solid, do they conduct electricity? Why or why not? So pause the video now, then we'll go through them. So let's identify them first. So first we have copper, or you could just have said a metal would have been fine. Diamond, sodium chloride and graphite. Now, do they conduct electricity? So you want to be thinking about what electricity is. So that is the flow of charge. So you need to think which ones have a charged particle, whether that's an ion or an electron, available to carry the charge when they are solid. So copper, with its delocalized electrons, is able to conduct. Diamond is not. Each carbon is bonding to another carbon. There are no delocalized electrons, and it's a covalent structure, so there are no ions. Sodium chloride, when solid, cannot, because the ions are in a fixed lattice structure, but in its molten or aqueous form it can, but in solid form, no. And finally we have graphite, which each carbon is bonded to 3 others, so there is a spare or a delocalized electron, to use a better term, which is able to flow throughout the structure carrying the charge. So what is electrolysis? So we get a bit of Latin here. Electro referring to use electricity, and lysis being Latin to split or to break apart. So electrolysis is basically breaking, splitting up compounds with electricity. So if we look at the cells, we've got our anode, which anions are attracted to, and we have the cathode, which cations are attracted to. So the anode and the ion have different charges, but you've got to think of it as the electrode is named after what it attracts, or what's attracted to it is named after the electrode, depending on how you want to see it. So easy mnemonic that is commonly used is panic. So positive is anode, negative is cathode. We'll also emphasise, if you're in an exam, don't panic. You can just call it the positive and negative electrode if you are worried. So we're going to be looking at ions and atoms in this. So I want you to have a little think, pause the video and have a little review. State what is shown in each picture and write how you'd represent it in a balanced symbol equation. Pause the video now if you haven't already. So first one, we have 2 sodium atoms, and we'd write that as 2 capital N lowercase a. Then we have 2 chlorine atoms, that'd be 2Cl. Then we can see we've got a diatomic molecule here, so the 2 chlorines are attached to each other. So we have 1 chlorine molecule, and that is Cl2. Then we have 2 sodium ions, that'd be 2 Na+, 1 chloride ion, Cl-. You will get picked up if you're using "-ine" or "-ide" on the end of the words incorrectly. Then we have the oxide ion, which is O2-. Now we know these ion charges from what group most of these are on the periodic table. If it's in group 1, it will lose an electron, it becomes positively charged. If it's group 7, like chlorine, it will gain an electron, become a -1 charge. Oxygen is in group 6, it gains 2 electrons, hence 2-. So why do we use electrolysis? You should be aware that because electrolysis requires lots of energy, it is an expensive process. So it's not your first go-to method of purification when dealing with ores. So the reason why we use it on those substances which are really reactive, higher than carbon in our reactivity series. And you can see one in the picture in front of you. You do need to know this reactivity series for your exams, okay? They don't give it to you in the data sheets anymore, so you need to find a way to memorise it. So what is going on in electrolysis? So we have a very simple diagram here showing our anode and our cathode. They will normally tell you the anode and cathode, or tell you the charge, but they may not always. So you do need to be able to recognise from the direction of the cell battery in the top of the diagram that might be there, which will be which. So if the long thin one is the positive electrode, the thicker one is the negative electrode. So at the anode, negative ions are going to travel to it. Okay, and those negative ions are called anions, as we mentioned earlier. And those anions will lose that electron to become an element at the anode. This is oxidation. So if you remember, oil rig, oxidation is loss of electron, reduction is gain of electron. So at the cathode, we're going to have reduction. Positive ions travel to the cathode, they then gain electrons, and this is reduction, as we said before. At the cathode it's always reduction, at the anode it is always oxidation, so that's a nice easy thing that you can remember and put on the flash. So we're going to start with a simple example with just 2 ions present in the solution. So we have molten or liquid sodium chloride. And whenever you're looking at an electrolysis question, your first thought should be what ions are present. And in this case, we're going to have Na plus, sodium plus 1, and Cl minus. Okay, and you need to use your periodic table and your knowledge from the C1 module and C2 module to help you work those out. So let's look at the anode. At the anode, our positively charged electrode is going to be attracting those negative ions. So in this case, the chlorine is going to travel to the anode. The chlorine is going to lose an electron when it's at the anode, and this is oxidation. So we can write this as an expression or an ionic equation. So we have Cl minus 1 electron forms chlorine, the element. And that is a valid expression that you can write, and it's normally my first starting point. But there's 2 things to consider. We don't get Cl or chlorine by itself. It forms a diatomic molecule, so it'll bond with another chlorine to form Cl2. That means we need to double everything in that expression. So we now have 2 Cl minus 2 electrons forms chlorine. So that's okay, but we want to make this a proper chemistry answer, so we need to rearrange that equation. We have the etiquette in chemistry that we always write plus electrons, and this is to do with where we get to in a later stage in chemistry A level. So you need to write out the correct expression for this would be 2 Cl minus aqueous goes to Cl2 gas plus 2 electrons minus, and you can see I've added the state symbol there, and they're important too. So try not to forget those. Now you will generally get the marks for writing the previous expressions that are written in black because they are technically valid, and if you add the state symbols you should be okay for the marks, but the answer in red is your perfect answer there. At the cathode we've got sodium travelling there. The sodium is going to gain an electron to reform back to its original electron configuration, and this is reduction, and we can express this as Na plus aqueous plus 1 electron goes to Na sodium solid. So I've just shown you an example with molten sodium chloride, but we don't actually often do that in the real world because it requires a lot of energy to get sodium chloride into a liquid state. It's a giant ionic structure, they have high melt and boiling points, you might well remember from C2. So, more often we have aqueous NaCl, or seawater basically, and we can electrolyse that and we can see what will happen. Now, I said earlier the first question you need to have is what ions are present. And this time we've got more ions. We've got the Na plus and Cl minus still, but we've also got the ions from the water, so H plus and OH minus. This now means we have 2 different species travelling to each of the electrodes. So we have chlorine and hydroxide travelling to the anode, and we've got sodium and hydrogen travelling to the cathode. So what will be discharged? So in chemistry we have something called preferential discharge, and that's where the least reactive substance is discharged at the electrode, and the most reactive substance will stay in solution. You kind of think of the more reactive substance as putting up a bit more of a fight, doesn't want to leave the party. So at the cathode, the hydrogen ion is discharged in preference to the zinc, aluminium, magnesium, calcium, sodium, potassium ions. But the copper and silver ions are discharged in preference to hydrogen ions. Now if we have H plus being discharged, it's going to produce hydrogen gas, so H2. At the anode, we've got the hydroxide ion being discharged in preference to the sulfate, and chloride and bromide ions are discharged in preference to the hydroxide ion. If you have the hydroxide ion at the electrode being discharged, you're going to produce oxygen gas. Now all this content for preferential discharge is higher tier content. So if you know you're going to be doing the foundation paper, you don't need to stress about this so much. So let's go back to our example of aqueous sodium chloride. We've identified the ions are present, and now we wanted to work out which one is going to be discharged. So we had our chlorine and a hydroxide, and as we had in that table, chlorine is preferentially discharged. So we're going to have the same expression that we had last time when we looked at the molten sodium chloride. So at the cathode, we identified the sodium and hydrogen ions were travelling there. And so what is our least reactive substance? That's going to be the hydrogen. So in the molten liquid case, we had sodium being discharged. Now we're going to have hydrogen. So we're going to have the hydrogen ion gain electron to form the hydrogen atom. And as we said, it doesn't form hydrogen by itself, it's diatomic. And so we can improve our equation as shown. We're adding state symbols, and we've multiplied all our components to be able to get H2. So here's an exam question. It's about electrolysis, unsurprisingly, and you are going to electrolyse silver nitrate, and they've given you the chemical formulae there. So name the product discharged at the electrode. Write a half equation for the reaction at each electrode. So pause the video and have a go at this one. So you're asked to name the products. So at the negative electrode, we're going to have the positive silver ion going there, and it's going to react in this way. So we've got Ag plus 1 electron forming Ag. And the product at the positive electrode is going to be oxygen. And so we get 4H minus forming O2 plus 2H2O plus 4E minus. Next question, we are going to look at our example we've just looked at. We are going to electrolyse sodium chloride solution. So they expect you to know that it is aqueous. And they've helpfully told us that those bubbles of gas that you'd see at each electrode are chlorine and hydrogen. Explain how another different product is formed in the solution during this electrolysis. So, you state what ions are present at the start. This are H+, OH-, Na+, Cl-. That's going to get you 1 mark. You then want to say the hydrogen is discharged at the negative electrode and the chlorine at the positive electrode. Perfect, you've got yourself 3 marks there. That leaves behind in our solution an OH- and an Na+. So we're getting left behind with a sodium hydroxide solution.